Okay, Pedro, here we go. Problem 40 and problem 42. Let's first make sure that you know that you have to, these are called rational equations because there's fractions with variables in the denominator. And the first thing we want to do is make sure every denominator is in factored form. And that means for this denominator, we're going to factor out a 4. And to help you visualize this, I'm also going to put some of these numerators and this denominator in parentheses to emphasize the fact that x minus 3 is like a number. They're not factors. They're not being multiplied together. And that's an expression. That's an expression. So is the x for that matter. One thing we do when we solve rational equations, I'm going to make this my scrap paper in the middle here, is we want to make note of the fact that the numbers that x cannot be. So if we look at these denominators, we see that if we ended up solving this equation and got an answer of x equals 3, we'd be putting 0 in a denominator. So we're going to make a mental note or a written note that we will not accept an answer of 3 for this problem. Now the next question is, what is the LCM? Because that's what we're going to multiply every term of this equation by to clear the equation of fractions. And you might want to make note of the fact that this 4 is really 2 times 2. So if I look at the factors that are here, there's an x minus 3. I just start writing the factors of each denominator. Then I move to this denominator and I see I need a factor of 2. Then I move to the next denominator and I see that this 4 can be thought of as 2 times 2. So there's 2 factors of 2. So I need another factor of 2. And I could write that this way. And I've already got an x minus 3 listed in the LCM. That's your LCM right there. Because every one of these denominators will divide into here evenly. Now let's see what happens when we take this LCM times this first term. This is what you visualize. You don't have to write it down necessarily. But if you have to, come over here to scrap paper. Here's that first term. And I'm going to multiply that term by the LCM, which is 2 squared times x minus 3. And if it helps, visualize it over 1. The whole point is that these factors cancel out. And all that remains in the numerator after canceling out the x minus 3's is a 4. 4 times x. So when this first term is multiplied by the LCM, I get 4x. Now this minus sign kind of travels with the numerator, but let me again show the work involved. I'm going to multiply the second term minus x minus 2 over 2 by the LCM, which is 2 squared times the quantity x minus 3. And I can think of this as a minus 1 right here. And this is all over 1. What cancels out? one factor of 2. Go to red here. So one of these factors of 2 cancels out. So I've got 2x minus 6. That's from distributing the factor of 2 that remains times each term inside the parentheses. And then I'm going to take this minus 1 times inside each of these each term inside times each term inside of this parentheses. So I'll get minus x plus 2. Go ahead and write it that way. And then we're eventually going to have to FOIL this out, so I might as well do this here while I'm on scrap paper. So 2x times minus x, that's the product of the two first terms, that's minus 2x squared. The outer product is a plus 4x. The inner product is a plus 6x. Minus 6 times minus x. And minus 6 times plus 2 is minus 12. So in the end, this simplifies to minus 2x squared plus 10x minus 12. And again, this is the kind of work that I encourage you to do out here in scrap paper. And then take all of this and move that to your homework paper or your test paper or whatever. That's what we're going to get when we multiply this second term by the LCM. Minus 2x squared plus 10x minus 12 equals. Now when I take the LCM times this term, well, that is the LCM. 4 times the quantity x minus 3. So those are both going to cancel out, and all that's going to be left is a 5x minus 3. And since this is a quadratic equation with linear factors, that means eventually we're going to have to get all the terms on one side and set it equal to 0. So I'd simplify my work here. I'd say negative 2x squared. I'd combine some similar terms over here and lightly cross out the ones that I'm combining or finished with. So I'm done with this one. 4x and 10x is 14x. So I'm done with these two. I've got a minus 12. And I've got a 5x minus 3 on the right side. So let's collect all the terms on the left side, which means we have to move these two, the 5x and the minus 3, back to the left side. So I'd have minus 2x squared. When I transpose the 5x over, or subtract 5x from both sides, I'll get a 9x. And when I transpose the minus 3, it'll become a plus 3, so I'll get minus 9. I'll tell you one thing I hate to do is work with a minus in front of the x squared. So I'm going to change every sign to the opposite of what it currently is. That's like multiplying both sides by negative 1. 2x squared minus 9x plus 9 equals 0. Now does that factor? Right now I have no idea. Someday maybe you and I will talk about the box method. I'm just going to kind of show you how I do this to see if it'll factor. Sometimes I go right to the quadratic formula, but I would say, let's see, a times c is 18. Positive 18 So I'm looking for multiples of 18 that have a difference, that have a sum of minus 9. Sum of minus 9. This is scrap paper work here too. So what's some multiples of 18? Well, there's 18 times 1. Those add up to 19. There's 2 times 9, or 9 times 2. Those add up to 11. There's 6 times 3. Those add up to 9. That's what I'm looking for. So, and I want actually to have a minus 9. So these both have to be minus. And then we use this technique called the box method, or factoring by grouping. We put 2x squared here. We put a plus 9 here. And then from these multiples that I just went to all this trouble to discover, I put minus 6x and a minus 3x in these boxes. And it doesn't matter which box I put which in. And then we factor out from each row the greatest common factor. So from this first row, there's a 2x. From the second row, I can factor out a minus 3. And I always use the sign of the first box. So I factor out a minus 3. And then I ask myself the question, what times 2x will give me 2x squared? That's an x. Or I could factor out the greatest common factor from the first column. And what times negative 3 will give me positive 9 plus 3. So my contention is that 2x minus 3 times x plus 3. Whoops. Pausing the video. I see what I did. Usually I write the other binomial on the top, so I should have used a minus 3 here. Because minus 3 times minus 3 is plus 9. So the factoring of that trinomial is 2x minus 3 times x minus 3 equals 0. And you can double check it by FOIL. And some students are fine with using trial and error to see if this will factor. You can also go to the quadratic formula. But 2x squared minus 6x minus 3x is minus 9x, and minus 3 times minus 3 is plus 9. So 2x minus 3 equals 0. Or x minus 3 equals 0. And here, if I solve for x, I get x equals 3/2. Or x equals 3. But look what we wrote up here. 3 cannot possibly work, because if I put 3 in for x, I get 0 in a denominator. So this is a solution that doesn't really work. That's your answer right there. And if you don't believe it, put 3/2 in for x, and I'll bet you can make the left side equal the right side. Okay, now I'm going to come over here to 42. Rewrite this like this. I'm going to put all these binomials in parentheses to emphasize the fact that they are the factors. And my guess is that this trinomial factors as x minus 2 times x plus 5. And for sure it does. I get the plus 3x in the middle. I make note of the fact that as I solve this, I will not accept an answer of 2, and I will not accept an answer of minus 5. I'll make note that the LCM, I'll write down the factor from the first denominator, that's an x minus 2. I'll write down the factor from the second denominator, that's an x plus 5. I move to the third denominator and I say I already have an x minus 2 in the LCM. I already have an x plus 5, so that's your LCM right there. So I'm going to multiply that LCM times every term. If you just kind of write it up here, you can visualize it. When I take this LCM times the first term, the x minus 2's are going to cancel out, and I'm going to have an x plus 5 times 1. Then when I take this LCM times this term, the x plus 5's are going to cancel out, and I'm going to have x plus 2 times x minus 2. And when I take this LCM times this fraction, both factors of this denominator are going to cancel out. So I'm just going to have a factor of 3 remaining. We got to multiply these two binomials together. They're a difference of squares, so I get plus x squared minus 4. It's a quadratic, so I need to have it equal to 0. I'll rewrite it in descending order. X squared plus x plus 1 equals 3. X squared plus x minus 2 equals 0. I'm looking for factors of minus 2. Or multiples of minus 2 that have a difference of plus 1, the number in front of the x. Well, there's only 2 multiples of 2. They're 2 and 1. And they do have a difference of 1. I want it to be a positive 1, so I put the plus here and the minus here. And since there's no, the leading coefficient of x squared is 1, this is easy to factor. You don't need to actually use the box. X plus 2 times x minus 1. So x equals minus 2, or x equals 1. Neither of those is in our unacceptable list, so these should both work. Let's just try. I'm going to erase this scrap paper because it's on video. So you can copy down that scrap work if you need to. And let's just take a look at how we check those answers. So let's check the 1. That looks like an easy one. I'm going to put 1 wherever there's an x. So 1 over 1 minus 2 is a negative 1, plus, put 1 in for x, I get 3 in the numerator, 6 in the denominator. Does that equal 3 in the numerator? Put 1 in for x, I get 1 plus 3 is 4. 4 minus 10 is negative 6. So this is negative 1 plus a half. Does that equal negative 1/2? This is negative 2/2 plus 1/2. Does that equal negative 1/2? It sure does. Check. And you'll get the same results if you put -2 in for x, that you'll find that the left side equals the right side. So there's your solutions to number 42. Let me know if you have any questions. Number 40 definitely was a lot harder, especially since we had a root that didn't work. The 3 didn't work. Okay, and I kind of glossed over the box method for factoring trinomials. It's a good method to use if the leading coefficient on x squared is greater than, it's not equal to 1, I should say. And if you need to talk about that, as a matter of fact, I'll send you a link to one of my videos on the box method. And I'll save this one and enjoy.